Hey everyone, Mr. Fugay for another geometry video for you today. We are going to talk about radians, a different way and a more efficient way in the big picture of how to measure angles. So we have a few things to get started with. First off, I want to talk about unit conversions because we're essentially learning a brand new unit. We've learned how to measure angles in degrees, and now we're introducing this new unit. Well, lengths like miles and volumes like gallons are customary units we use in America. But in a lot of other countries outside of the United States, kilometers and liters are used. And so we have to be able to use conversions here as well. So let's do a quick review. Let's talk about this. So I'm giving you the conversion factor that 1 mile is the same as 1.609 kilometers. So in the first example, if I want to convert 2.5 miles into kilometers, here's what I'm going to do. I'm going to take my 2.5 miles, we're going to write the units there, and we are going to multiply it by the ratio of 1.609 kilometers over 1 mile. Now I'm writing the ratio as kilometers over miles specifically because I want to cancel my mile unit. And so that means that the final answer is going to be in kilometers. And what I'm going to do simply is just multiply 2.5 by 1.609, and we're going to get an answer of approximately 4 kilometers. Now this works in reverse as well, so that if we have 5.2 kilometers and I want to take this and convert it to miles, the ratio that I'm going to choose this time is going to be miles over kilometers. And that's going to allow the kilometers to cancel out. Now when I'm putting here this ratio, obviously has to be two equivalent things. So 1 mile is equivalent to 1.609 kilometers. Those are equal to each other. Essentially, you're multiplying by 1 over 1, if you think about it. So what happens is that the kilometers cancel. Once again, we're going to get miles as our final answer. So this time, really, it's 5.2 divided by 1.609, and we're going to get an answer of 3.2 miles. Let's try this one more time. So if we have 26 miles, and I want to convert this to kilometers, I would put miles in the the denominator, and kilometers in the numerator. So this is 1.609, and 1 miles will cancel. We'll have kilometers as our answer. So the final answer is 41.8. I want you to take a moment now using this concept to see if we can convert these gallons and liters into their other units. So go ahead and pause and try this out. Like magic, here we go. So from gallons to liters, we would multiply. So if we wanted to convert gallons into liters, we're going to multiply by liters over gallons so that the gallon units cancel. And then conversely, if we want to convert liters into gallons, we would multiply by gallons over liters to allow those to cancel. Now we're going to need this idea in just a few moments because while we can measure distances using kilometers and miles, and then we can measure volumes using gallon or liters, angles can be measured using both degrees, which is what we are mostly familiar with at this point, but now this new unit we have called a radian. So we're going to focus on the radian part of this today. So what is a radian? Well, hopefully watching this video, you've had a chance to try the rubber band activity that we do in class or something similar. But regardless, the idea behind a radian is if we take the radius of a circle, like that red line, and then we take that red line, and I can't do it on here, but I rotate it, and then I would bend it. Now I can't bend it on here, so let's just draw it. And I would bend that radius, and right there, that is 1 radian. So 1 radian is essentially taking that same radius, turning it and bending it to create an arc. That arc is 1 radian, and what we found through our activity is that is approximately 57.295 degrees. Now, we're not going to remember it that way. Another way that I want us to think about this is that we have 1, 2, 3, 4, 5, 6, and then some part of another sector that creates this full rotation, 1 revolution. We know in the land of degrees that that's 360. That is approximately going to be, that's 0.28. This is roughly 6.28, and that is better known as the more exact value, 2 pi. So this is an equivalent, kind of like 1 mile is equal to 1.609 kilometers, 360 degrees is equal to 2 pi. Now we're going to keep this a little simpler. I'm actually going to look instead at a half a revolution. So if I actually just look at half the circle instead, so let's forget this bottom half for now, you'll notice that I have 1, 2, 3, and then this tinier sliver. That tinier sliver is 0.14. So 180 degrees, half a circle, is equal to 1 pi radian, so 3.14 radians. So that's another way for us to look at this when we're going through this problem. So I'm going to erase all this scribbles. We don't need that there. So we are now going to use this ratio to help us convert. So just a reminder, 180 degrees is equal to pi radians. And so we're going to use that to help us answer these questions down below. So we want to convert from degrees to radians in the examples on the left. So what we're going to do is essentially take that ratio again, and we're going to multiply it by, since I want to turn degrees into radians, we're going to multiply by radians over degrees. We know 180 is equivalent to not 2 pi, just regular pi. And all I'm now going to do is the degrees will cancel, and we're now going to take and just multiply 210 times pi over 180. The number 210 and 180, they both divide into the number 3 successfully, and that's going to, and actually 30 to be exact, that's going to simplify to 7 pi over 6. So there's our first example. So in the second one, once again, we have degrees. So what we want to do is we want to multiply by radians over degrees, because I want those degree units to cancel. So 180 and pi, once again, that's the equivalent ratio we want to use. If I multiply those out, this gives me 135 pi over 180. 135 and 180 do go into each other evenly. That would result in a simplification of 3/4. So we're going to keep these answers in terms of pi. We're not going to multiply the pi because that's going to create an irrational decimal, which is not an exact value. So we're going to leave the pi kind of frozen in time, and we're focusing just on the numbers 135 and 180 to come up with our result. So one more to try there. Why don't you take a moment and pause and see if you can try the 88 degrees. Can we convert this into radians? All right, let's bring over that answer and let's see how we did. So if I move this over here, I have it a little bit more color coded this time, but notice we're still going over pi radians over 180 degrees. The degrees cancel. We get 88 pi over 180, which simplifies to 22 pi over 45. Finally, in this first part of the video, we're going to flip the script. What if we have a radian, but we instead want to convert it to a degree? Well, how does that work? Well, in this case, we're essentially going to do the same thing we did before. These are measured as radians. I'm going to just write RAD to help you with the unit conversions here. We're going to want to multiply by degrees over radians this time. And the reason why is we want the radian unit to cancel and to have the degrees as my final answer. Well, what's that equivalent ratio? Once again, it's 180 over pi radians. Now, one other thing that's going to cancel is not just the radians, but almost always the pi's are going to cancel, because I have pi in the numerator for my radians in almost all the cases, and pi in my denominator. So really, all we're doing to get our final answer for this one is doing 3/4 times 180, which means we're going to get an answer of 135 degrees. So that is the degree equivalent of 3 pi over 4 radians. Using this same idea, once again, we're going to take and multiply by degrees over radians, and it is 180 degrees over pi radians. So the radian unit cancels. Once again, the pi unit cancels. So ultimately, all we're doing is 5/3 times 180. And when I do that, we're going to get a value of 300 degrees. Go ahead and pause the video one last time and see if you can convert pi over 9 radians into degrees. So let's take a look and see how we did here. There is my work. So once again, we're going to multiply by 180 degrees over pi radians. Radians cancel, pi's cancel. Now, if there's no pi, by the way, the pi will not cancel. So just be careful. I'll even add that here. If the radian value does not have pi in it, so does not have pi, don't cancel the pi. You only cancel the pi if the radian value has pi in it. So you would actually do the division of pi and you would get some decimal answer. In this case, because there was nothing left in the numerator, really that's the number 1/9. So really what you're putting in to multiply here is 1/9 times 180, and that's where I'm getting my 20-degree measure from. So that will conclude this first part of the video, radians, degrees, and how we can convert between them. Be sure to check out part 2, where we're now going to talk about how to measure angles in standard position using this new radian measurement.